Okay, cool. Okay, so I can see Kat wants to know what we're going to do in this session. So, this is going to be an, somewhat interactive session. So I've got some questions from some of you, and I'll be talking a little bit about the questions I've received, and we'll keep it fairly open-ended. There's really it's not going to be similar to the other sessions that I have taken of what we usually have. It's more where I'm trying to help you guys get used to Python. All right. So assignment deadlines and stuff, guys, you can check with the support managers. I think they would have communicated to you the dates and stuff, right? So so that's for you, Kalpesh. You've just written to me. Those guys are the ones who look at the dates, so you can check with them. All right. So what we'll do is we'll start with. So I've had a few people who've asked me about the assignment. So Tat wants to know that if you have decent Python skills, what if? So I guess this is more for people who are not very comfortable with Python and want to get a little more comfortable. Tat, in case you manage to complete the assignment without too much trouble, maybe this session would have limited utility for you. Okay. All right, so so I've got a few people who've asked me some questions about the assignment. So I'm going to just talk a little bit about each question. All right, and then we'll go take it from there. All right. So the first question in the assignment, which has been given to you, is to write a function to calculate the factorial of a number. So I'm sure most of you would already know that when you talk about a factorial, right? Let me just clarify anyways. So when we talk about the factorial of a number, say n, it's basically denoted as n factorial, and this is equal to n into n minus 1 into n minus 2 all the way up to 1. So for instance, 4 factorial would be 4 into 3 into 2 into 1. So that's like 24. 6 factorial would be 6 into 5. So that's I think 720, right? So the point is, we are looking to write a program which calculates it for us, or rather we are looking to write a function. So as I have spoken before, when you talk, so first thing is, let's look at the what we've done with respect to a function, user-defined function, right? So what I want you to do is, I want you to create your own function. And let me just find the function here that we've done in class. I'm just going through last time's file that I shared with you. So we had spoken about functions and user-defined functions somewhere here. Yeah. So user-defined functions have a standard format where you use the def keyword here. So essentially, what I'm looking for is you create a function. Let's say like a def. Let's call it factorial, and maybe it has an input of n, and then you write your code block here, and then it returns the factorial. Now, what you're going to be doing, so it would return some value here. All right. Now, as you can see, when you compute the factorial of, let's say, 5, what you're doing is 5 into 4 into 3 into 2 into 1. So clearly at this point, right, you'll have to use some sort of loop. All right. So we've discussed 2 different types of loop in class. One was the for loop and one was the while loop. So you can use either of these and try and write a function to compute the factorial. So think about what steps you would follow if you were to compute, let's say, the factorial of 6. So if you were to go stepwise, you will look at, say, one number before 6, which is say 5. The number before that is say 4. So you can just keep, let's say, multiplying 6 by its previous number, which is say 5, and then you get a product, and your loop goes over and over again, where it keeps going back to a number which is previous to 4, and then previous to 3, and so on, until it reaches say 1, right? So you can use some sort of method. I'm going to leave it at that. I think I've given you a pretty good hint with respect to how you can go about this. All right. So Kalpesh wants to know if you can use a loop using lambda. You can try this, Kalpesh. I think I would rather that you try it and see what happens, and then in case you're having trouble, you get back to me, all right, or just write to us. Yep, you tried, and then just send us back whatever you've tried, and we can then look at it and see if something can be done to make it work, or probably try and understand why it doesn't work. All right. Okay. So that's question number 1. Question number 2 says, write a Python program to generate a sequence of 1000 numbers drawn from a standard uniform distribution and plot it on a chart. Compute its mean. Use the np.where clause to create a sequence of numbers greater than 0.75 from the list. Plot a chart of those numbers. Check how many of these exist. Is it on expected lines, right? So, so there are several things you need to do in this question. And my objective of giving you this question was to get you familiar with the NumPy library. And within NumPy, I want you guys to start using the np.random sublibrary, right? So if you go through some of the the code that I'd shared last time, you'll see that, for example, I've shared a line saying np.random.normal and what it does for you, right? Similarly, there's another line I can see that I've written for you here, which is np.random.randn, right? So, for example, if we were to check what is to be done, once you import the library, one of the easiest things to do is just do an np.random and a question mark, and it gives you some idea of what exactly happens within this random number generation, right? So you have different functions within it. So you have random underscore sample, random underscore integers, and so on. Similarly, you have various distributions that are given to you, and we are looking specifically at the uniform distribution, I think, right, in the question. So we are looking at what is called the standard uniform distribution. So you want to generate a sequence of numbers from the standard uniform distribution. So let me talk a little bit about the uniform distribution. So when you say uniform distribution, right, we are talking about, so first things first, when you talk about uniform distribution, you're talking about a random variable which varies between the values 0 and 1, and it is it could be any value between 0 and 1. So the extremes are 0 and 1, and this is your PDF for it. So so there's an equal likelihood that the number that you pick could be anything between 0 and 1. So in any case, this is as far as the distribution of it goes, and you can basically try and use the different functions of the library to create a NumPy array, or you can create it as a list. I leave it to you how you want to create it. So for example, let's say I do something like np.random. Let's see, uniform, and I do say 5, and so rather I could just check what this does. So I basically I can choose you know, what exactly I want in this. So if I specify 0, 1, 5, for example, let's see what we get. So now you have an, let me just delete this cell. So what you have here is you created a uniform, I mean, you have created an array of 5 numbers that are all picked from a uniform distribution that has numbers between 0 and 1, right? So essentially what I want you to do in the question is, I want you to generate a sequence of 1000 numbers rather than like say 5. So I've just given you a hint on how you go about creating it. You then plot it on a chart. So for that, you can again look through what we've done last time. So you could use a method like dot plot, all right? So for which you need to import the matplotlib library. So let me just touch a little bit upon that. So, you know, the last time what we'd done was we had tried to plot a little, so we didn't spend too much time on plotting, but nevertheless, I did show you a couple of ways to use matplotlib, right? So we had imported matplotlib.pyplot as PLT, and we had done something like data close.plot last time. Now, instead of that, let's say, where were we now? Let me go back to yeah. So if we were to, let's say, plot, so let me first import matplotlib dot pyplot, and if I were to plot no, is I think X PLT, is it? No, hang on. So if I want to plot a NumPy array, plt.plot. Okay, I need to do plt.plot. That's right. So I do plt.plot and X. So, you know, this gives you a plot of, let's say, the array X that we just created. Yeah, so in the same breath, we could, you know, go about creating the plot of whatever we need. Now, I would want you to look up np.where. I'm not going to, you know, cover it here, but I do want you to look up, you know, np.where, which is a very, very useful feature within the NumPy library. It's one manner in which you specify a condition, and then you try to output whatever it is that you need. All right. So you use an np.where. So that's as far as this part of the question goes, and then go about doing it. I just want you to, you know, whenever you solve this question, I want you to start it with an np.random.seed 1, 2, 3, 4 at the beginning. So the idea of doing that is, you know, when you draw from, or rather when you create, you know, a series from a random series from a distribution, you could be picking any set of numbers. So by seeding it with a specific number, what I'm trying to do is I'm trying to make the, you know, the samples that every one of us picks the same, exactly the same. So that's the purpose of, you know, adding that one line at the beginning, np.random.seed, all right? I think question numbers 3 and 4 should be fairly straightforward, which is the method and function used to display rows and columns. So again, here, what I would want you to do is load the file onto your system, and then essentially start looking up what are the different things you can do in a data frame. So, you know, one is some stuff that we've done in class, and the second is skimming through the pandas documentation. That's again my purpose of sharing this question with you. The same thing goes for, part 4 also, question number 4. We are again going to be using that. Now, before I go ahead, let me just look at a couple of the questions that have come my way. So Tejas has some question to do with futures and options data. So Tejas, I guess we would have received this question, and someone from our team will take a look at it and get in touch with you. All right. Okay, so there were some questions with respect to the magic commands that we used last time. Okay, I received it. We received some of those. So just to touch a little bit upon magic, guys. So when we use the Jupyter Notebook environment, all right, what we are essentially doing is we are using. So the thing with Python is that there are multiple ways in which you access the Python interpreter, and one among them being the Jupyter environment, okay, which is essentially using what is called the IPython interpreter, which is the interactive Python interpreter. Now, because it has so many different ways by which it can be accessed. So for example, you can access it through a traditional IDE like Spider. You can access it directly through IPython. You can access it just on the Python command shell, etc. What magic commands do? So firstly, these magic commands are applicable in an IPython setup. So because Jupyter is used as a wrapper around IPython, you can use magic commands there. So to recap what I had said the last time, any command that starts with a percentage operator is what is called a magic command. And what you're trying to do is you're trying to enhance the functionalities of your Python by using magic. Now, specific to matplotlib. Now, so I'm going to be talking about matplotlib in our next session in any case, before we get around to doing strategies. But maybe I'll just touch upon one aspect of matplotlib here. So this particular library is primarily used for plotting, all right? And it was born out of the need of MATLAB users who were trying to migrate to Python. Hence, even the name matplotlib. It literally comes from, it's like a MATLAB plotting library of sorts, all right? Now, the thing is, this particular library gives you multiple ways to output the plots that it comes out with. So for example, there could be cases where you want your plot to pop out in a different screen. There could be times when you want your plot to appear right below your code, all right? So this whole idea of putting a percentage matplotlib inline is to essentially tell your IPython interpreter that you want the graph to appear right below your command. You don't want it to pop out separately, all right? So that's the purpose of using something like percentage matplotlib inline. Again, some of you are asking me for possibly some books or recommendations for pandas and NumPy. I think the last time, if you go through the files that I've shared with you, right, and you scroll right to the bottom, you will find a list of references that I've shared, and I think you'll find some pretty good books there. So I really personally am very fond of the pandas documentation. It's humongous in size, but especially when you start looking for specifically things that you want, it's very informative. It's huge. If I remember correctly, it's well over 2,000 pages, and it's not possible for you to read it from cover to cover, but you can keep referring to it whenever you need it. All right. There is one book by Michael Haidt which is also pretty good. It's called Learning Pandas, which I have skimmed through at one point, and I quite liked it. So I can see some questions about how do you debug a program. So the guy, this entire process of data analysis and writing a program is trial and error. So you will make these mistakes. So by and large, a simple way to a simple principle that I usually follow when I'm trying to debug some program I've written is I keep inserting some sort of print statements in the middle of a program that I may have written, so that at each stage I know whether the processing that I expect is happening or not. Now, so far we haven't written very complex programs because it's still early days in our journey. But as we move along, I will share with you methods that can be used in order to try and debug programs. Secondly, again, last time the other thing I had mentioned, and this is not specific to do with debugging, it's more to do with understanding errors, is that I had shared, I don't know whether you've had the time to see it, but you'll see that I have shared 2 links with respect to interpreting errors in Python. So and this is one of those things that you should be you should constantly read this from time to time, just so that whenever you encounter errors, you'll figure out what's probably going on, right? So you can take a look at both links. One is from the official documentation, and the other is another link which I found quite useful in my own journey. Okay, all right. So these were to do with the question numbers 3 and 4. Now, when I talk about question number 5, it talks about iterating through a sequence of 50 randomly generated integers and creating 2 different objects. So here also, I think a couple of people were a little confused with the question. So essentially, what I'm trying to do here is I want you to create a list of numbers. So again, this creating randomly generated integers, it again needs you to understand certain functionalities of the NumPy library, which you would anyways have got some understanding of because of question number 2. Once you do that, so now you're going to have a list of 50 numbers, and essentially I've given you 2 conditions. So in one case, I want those numbers to be even multiples of 3, and in the other, I want it to be odd multiples of 5. So you basically again you need to use a loop, right? So we've learned, like I said before, we've learned for and while. A question like this, probably a for loop might be more useful to you. I can think of using for some variable name in, and then the sequence that you have, and then it keeps traversing through that sequence, checking for those conditions that I've specified. So within the for loop, you'll have some if conditions. That's what's going to happen in question number 5, right? So that takes care of this. Now let me look at questions that came up, people who had written to me. So I think some people had questions to do with the matplotlib library. Now, like I mentioned, so I'm going to spend more time talking about the matplotlib library next, in our next session. I don't want to use this, doubt clearing session as one where I start giving a lot of information on matplotlib, because many of our friends are not there today. And in any case, I had planned to cover that for the next class. All right. Suffice to say for now that it's a top quality library. However, as I mentioned before, it had been created with a certain objective in mind. But of course, as the project started growing in size, its scope expanded. So it was initially, trying to address MATLAB users who needed plotting functions. But eventually, as it became more and more popular, there were many people who came to the library without having a MATLAB background. They were basically Python programmers who wanted plotting functions. So it almost, in fact, ended up developing in two parallel streams. One for people who have some familiarity with MATLAB and want plotting functions in Python, and one for new or fresh Python users who wanted some good pretty looking graphs and plots, basically, right? There were some questions to do with using for loops in Python. So now the thing is, I think I had touched upon this a little bit, and we'll talk a little more about this next time, which is that a language like Python is not really geared, or it's been designed in a way where you can actually not use for loops. In the sense, you can do a lot of the functions without any loops because of what is called vectorization. And this comes into play when you start using other libraries. So if you were to use just native Python without any libraries, you would be essentially using for loops. However, the moment you bring in NumPy and pandas into the picture, things can get much faster. All right. So there was a student who sent me an example where he went on to talk about how it's taking a lot longer because he was using a for loop. So what I would want to add here is really the solution to that problem is vectorization, which I had touched upon briefly last time, and which we will be looking at more extensively when we get into serious programming from the next class. All right, let me see. Yeah, so I think if you go through my notes from last time, you will see that I had spoken about the fact that vectorization is essentially involves the elimination of a for loop in performing certain tasks. All right, so you are trying to save clearly save time when you use it. All right, and memory resources. So Kapil wants to know whether vectorization is more useful in backtesting. Yes, absolutely. And when we talk about real-time testing, again, Kapil, I'll hold off and sidestep that particular question for now. When we get on to those sessions where we talk about what we do with real-time data, all right? So let's park that question on the side for the time being. But it's a good and a valid question, and it will come up when we get on to real-time testing, all right? Okay. Let me see what else I wanted to talk about. Okay, so I think a couple of participants wanted me to talk about CSV files and handling CSV files. So let me go back to the part where I loaded a CSV file. So the last time what we did was we had a file called tcs.ns that we used, and we loaded it into Python using the pandas library, right? So maybe let me just talk again about what we had done last time. So let me erase this whole thing. So I say data. So let's start getting comfortable with the tab complete feature, which we tried to use the last time, right? Have I imported the pandas library? Let me just. Okay. So the moment we want to read a CSV file, right? We can specify what file it is that we want to read. In case of the file that we are using, our index is basically the first column of our spreadsheet, and so the numbering anyway starts with index 0. So we basically say index underscore call equal to 0, and there's another flag that we use, which is parse underscore dates. Now the purpose of, so let's try and understand what is happening in each of these parts. So in the first part, you're specifying the name of the file. In the second, you're specifying that the index is going to be the 0th column. And in the third part, you're essentially specifying that you want to check if there are dates, or is there a date column within your spreadsheet, and you're asking it to check whether by parsing through and checking whether if it exists, right? So we've done that. Yes. So one of the classroom participants wants to know that in case I just, let's say, import, okay? So suppose I just import it like this. So suppose I import my data file, and I do, let's say, data.head. What you'll find here is that date is a separate column. So you can see what's happened here. You can see that there are different columns, date, open, high, low, etc. And you can see that there's a sequence of numbers here, 0, 1, 2, 3, 4, which means that the index is separate from the dates. right? So which means you will not be able to use the power of your index of dates itself, because despite it being dates, pandas doesn't know that it's a dates column. So let's say I look up what's happening with the date column, right? So let me check what type it is. So it's just being stored as a series. The date column itself is being stored as a series, and so let's and the values within the date column are being just stored as a numpy array, which means it's not getting, so you're not able to exploit its true value. The true value of of that column is that they are dates, basically, right? So let's say at this stage I realize that what, I'd like it to become, I'd like to change my date column. So I would do something like data.index is equal to where I basically specify that. Let me remember how you do this. Let's check. I think it's data.reindex if I remember correctly. So here's the other thing. Having this tab complete means that you don't really need to remember every possible functionality within pandas or any of these things. So for example, I don't exactly recollect. So if I want to reindex my data frame, there are ways by which I could do that. Okay. So I could for example specify, I'm just looking through the documentation here. So for instance, I just do data.reindex and I specify whatever it is that I need. So let's just try that here. Okay. So I say index equal to so now let's see what happens to data.head. Okay, so now this is not worked. So instead, what we could do is in place. Okay, so let me just. No. Okay. Oops. Okay, so 1 minute. So maybe what I'll do is I would do something like index underscore call equal to 0. So I specify that the index is the first column, and then I could just look up and check how this has been stored. So here the index has not been stored as a date. All right. So sometimes what might happen is the index itself needs to be stored as a date. So there is a function within pandas called pd underscore to date time, which we sometimes use. So it converts our index into what is called a date time as part of the date time library, as an object within the date time library. In any case, so again, specific to this aspect, I'm going to touch upon this in the coming class, but I've just given you a taste of what happens when it comes to loading data. All right. Okay, 1 minute. So there's a question that a student has asked me here. Okay, so Tyagarajan wants to know, how does a program know which folder to look for in the CSV file? So Tyagarajan, what happens here is that let me show you how this happens. So let me import a library called OS, and within OS you have something called get current working directory. So in my case, the current working directory is the desktop. Okay, so my files are really speaking lying in the on the desktop, whatever it is, and so it's looking for stuff in the desktop in my case. All right. So essentially that's what happens. You can you can also change, I think it's os.chdr, if I remember. If you do os.chdr, you can change the current working directory. So you can basically just look this up to see if you want to change your current working directory and point it to someplace else. All right. Okay. Yeah. So you'll have to just try this and see. When you mention it, sometimes in certain environments the slash needs to be forward or backward. So those little things you'll need to look in. But yes, you can specify. You can specify the whole path of where you want your working directory to be. Right. Okay. Kalpesh says, I have a question. When we use return. I'm not quite sure I understand your question, Kalpesh. Let me check what is it that you're saying. So if I do data.describe, it's so include. So the thing is, I think you wanted to know what is it that you can do within include and exclude. So within include, it would say, you want all columns of the input will be included in the output, and if you want the description or the summary descriptive statistics of only some columns, you can specify what columns you want here, or yeah, I guess that's I think what you need from here. So essentially what you'll have to do in cases like these is, right, when your requirements are very specific, you'll have to go through the documentation and try these things out. This is one way. So when you're trying to find information on something that you're trying, one way is, the easiest thing to do is just putting a question mark and checking. The other thing is more, actually doing a web search and trying to find what something .describe does, right? So the whole idea of getting into actually writing programs is that, on one hand, so I really think that to become good programmers, or to start getting comfortable with writing Python code, you don't have to know everything. What you need to know is, so for example, you need to have this arsenal of basic knowledge, which is of all the different packages that you have in the ecosystem. You should be comfortable with things like a tab complete, because that gives you an idea of what are the various things that can be done, and trying to find answers to those smaller questions. Because if you spend any amount of time on the while you're working, right, you will find that there's enough and more information out there, whether it's official documentation, whether it's portals like Stack Overflow, or whether it is the help that you find even within your working environment, using things like a question mark or a help with parentheses and specific to what you need, right? So that's what I would suggest. Let me see if, yeah, just one second, I'm trying to. Okay, yeah, go on. Mm-hmm. Mm-hmm. One second, let's try that. So we've imported OS. So okay, so what you can do in a case like this is, maybe you can try dir OS. So in this, you should be able to see, yeah, so here you can see the get CWD.
So what's the difference between both?
Yeah, right. So I think the so the question mark, right, it works well when you are looking for something very specific. So for instance, if I do os dot and I do a tab complete, and I want to look up, say, CPU count, right, and I do a question mark, it gives me a pretty good answer on what this function is.
Okay, so it's more precise, more specific.
Right. Whereas if you want to know in general what is there within the OS library, so the dir function is pretty good. The other thing that I'm now noticing with the dir function is, right, it enlists both public and private attributes and methods. So in Python, what you'll find is that there are a lot of private attributes and methods which are prefixed and suffixed with double underscore. So for example, double underscore all, double underscore built-ins, double underscore, and so on. So these are aspects to that library or to that function which are which you won't find in all of them, right? So for many of those different functions, they don't have those prefixes. So in case you want to see those also, you'll need to do a dir. So what I mean by private attributes is, so we've imported pandas, right? So pd dot double underscore. So if you want to know the version of your pandas, you can do pd dot double underscore version double underscore. So this just tells you the version of your pandas. It's a private attribute of pandas which doesn't. I mean, you wouldn't be using it as a function as such. This is just to know about the version that you have. So yeah. Okay, let me see. I think there were some questions to do with manipulating Excel sheets that, if I remember correctly, Ramit was the one who sent it to me. So Ramit, again, if you were to work with Excel sheets in general, right, within PD, within the pandas library, and if you do just a read underscore, you'll find that it can read many different file formats. So clipboard, Excel, Feather, JSON, and so on, including Excel. So if you want to read an Excel sheet, you just do pd dot read underscore Excel and do a question mark, and it will give you all the different things you can do. So so personally, I haven't used too much of Excel sheets specifically for my work. What I've essentially done when I have done my work is I try and get a raw data format like a CSV and then start using that to manipulate. That being said, the few times that I have used, I know for a fact that there will be attributes which access the specific worksheet within an Excel sheet, because in a typical Excel file you have multiple worksheets, and that needs to be specified. So I'm sure if you go through some examples that are given here, you'll get some idea with respect to what happens there. All right. Let me see where it's mentioned. Okay, so there's, I think, an attribute called sheet name, I believe. Is it? Yeah, so I think there is a parameter called sheet underscore name where you can specify it. Okay, let me see. Yeah, so Hamsaraj wants to know about how many stocks you can process at one time. So yes, I mean, so the thing with Excel is it's clearly a very, very useful tool, but the issue in Excel is, one is it's got the constraint of space. So if you're dealing with a file which has too many rows, so in fact you might have even encountered it in your work life, that if you have an Excel file which is, let's say, more than say 50 to 70 MB in size, and if you try and open it, it becomes very slow. Whereas you could have a CSV file which runs into the hundreds of MBs, and when you open it through Pandas or any of these, an R or a Pandas or a MATLAB or a Stata or any of these other packages, right? It's much faster because it just is stored in a more efficient way, and so on. That being said, Excel is incredibly useful when it comes to doing some initial analysis. I think in my first class with you guys also, if I remember, I did mention about the fact that I find Excel to be very useful in the most preliminary stage, where I'm just wanting to get, an idea, an overview of whether it's even worth spending my time pulling all this data and pushing it into Pandas and doing all this analysis. So that's where Excel can be incredibly useful. The catch, of course, is that when you're working on multiple asset classes and stuff, it becomes quite unwieldy to manage, right? Okay, now let me go to, and yes, Hamsaraj, you're right. You can load many CSV files and processes in Python and in Pandas, so that way it's much faster. Okay. So Tyagarajan says he's not able to plot the close price. So once you load your, so let's again load this with the parse underscore dates in place. So if you want to plot this, for example, I think we've done this in class. Let me check what we had done. So what we had done in class was that we had just we had run a line like this. Let's run it again now. So it should work if you run it this way. You basically just make sure you import the matplotlib pyplot sub library, and then all you need to do is you need to call the plot function on the specific column on which you want to plot it. In fact, you can let's say plot multiple columns too if you really want. So let's say I want to plot open. So you pass it as a list into to the plot function, and if you were to do that, you can have, let's say, both open and close. Because they are so close, you'll find that you can barely see enough of the blue. Right? Any other questions, guys? Classroom participants, online participants? So let's do one thing. Let's take a short 10-minute break here. And we'll come back and I'll see if there are more questions with you guys. And yeah, and then we'll take it from there. All right. So let's just break for about 10 minutes. Let's resume at 1700 hours on the clock that you see. So Daniel, I'll talk about what you just asked me in about 12 minutes. All right. Okay, hi guys, we're back. Let me just take a quick look at some questions. So Dan wants to know the structure of a data frame. All right, so let's first go to a part which I think is there in the sheet that I had given you guys, where yeah. So the thing is, when you talk about a data frame, there are three parts to it. One is what is called the index. Then there's columns, and then there's values. So the data frame that we've created, data, we can actually look up each of these. So if I do data.index, it tells me that the index of this particular data frame has been classified as what is called a date time index, which means, so you can think of it this way, that in the Python ecosystem, if you're dealing with an index which is a date or a time or a combination of both, and it gets classified in that manner, it means there are several kind of manipulations you can do with the data, which are possible because Python recognizes that it's a date. And in this case, because of the way we had loaded this particular CSV file, we have managed to do that. So it's being stored as date time index. All right. So this is as far as the index goes. If we were to do data.columns, it notice that it will tell you what each of your columns are, and that itself is stored as an index. So if you do let's say a type data.columns, it tells you that it's being stored as a pandas index. Similarly, you can actually look up and check how the index is also stored. So you can do type data.index, and it tells you that it's stored as a date time index. All right. So some things to note with regard to how it's stored. And then you have a third part to your data, which is called data.values, which is the actual values inside your data frame. All right. Now, the values themselves are actually stored as NumPy arrays. So if you were to look the type of what it's stored as, you'll see that it's NumPy arrays. And this would probably remind you of something I had mentioned, that the pandas library is built on top of the NumPy library. So here's the thing about NumPy. The data that you find in NumPy is basically homogeneous arrays. All right, the base data type. Whereas in pandas, you can have heterogeneous data within it, and it's often labeled. So you will have a label called open, you have a label called volume, etc., which gets assigned to pandas. So you can think of the pandas data structure, which is data frame, as an enhanced version of a NumPy array, where you have additional properties associated with it, which become very meaningful to you and me, right? Because let's say we are talking about in the finance context, we are talking about asset prices over time, or perhaps in a slightly different context, like let's say you're tracking online ad clicks, right? You could have a data frame which tells you the number of users who are reaching a particular portal and where they are coming from. Is it from a Google search? Is it from an ad click, etc.? So in that sense. So this is essentially the structure of your data frame. So yes, I mean, so this is, so let's look at data.index. So now that we're on it, so if we were to do data.index and check, you'll notice that it's basically a sequence of sorts. Okay, I don't want to call it so the index is basically like a sequence, right? And you can access different elements by calling its index number. So if I do data.index, say 100, it'll go to the 100th row in that specific sequence. So in this case, it would be the 23rd of October 2008 and stuff. Martin, you're right. It's some sort of metadata that gets stored within each of these. All right. Uh, Kalpesh has a good question. He says, are data frames two-dimensional only? Yes, the answer is to that is yes, Kalpesh. They are two-dimensional. So essentially, Pandas has three very useful data structures. One is called series, which is essentially you have an index and one set of values. So in I think earlier to this, we had just touched upon it last time. Let me find it. Yeah, so if you go through the material that I shared with you, right, I had mentioned that series can be thought of as a single column of data, and data frame can be thought of as multiple columns of data. Now you have a third type which is not used much, but it's still an important type, which is called panel. Okay, so the panel data structure within data frames is essentially three-dimensional. So it is the equivalent of having, so suppose you have the open, high, close, low of let's say here we have it for TCS, right? You could have it for other assets in the Nifty 50. So in other words, you can think of it as 50 Excel sheets. So the third dimension is each asset class. So that's basically what is called a panel data type. So now you have data on three axes. So you can think of it as the x-axis could be open, high, low, close. The y-axis can be the dates, and the z-axis is the asset. So it's like that's essentially what a panel data type is, which which might get used from time to time. So really speaking, when does it get used? It depends on the libraries that you start using. So when we start using different backtesting libraries, for example, so there are multiple backtesting libraries that we might start getting familiarized with. So for instance, Quantity has its own called Blue Shift, right? So each backtesting library has particular ways it handles this kind of data, and depending on if let's say one of our libraries is going to use the panel data type, at that stage we can spend some time trying to understand what it is. For now, at least, I think we can avoid getting into the panel data type for the time being. I think it's important that that we just understand that we will learn it when we get there. But suffice to say for now that the two most important data structures with respect to pandas are series and data frames, right? Okay. So Tyagarajan is getting some errors. Tyagarajan, can you share the last line of your error? You're saying it is showing a type error, but I want to see the last line of your error. So my sense is your data frame has not loaded, Tyagarajan. You'll need to load your data again. You'll have to run this line, read CSV, check whether data.head and data.tail works. So once your data frame is loaded, you should be able to see it. Okay. So Tyagarajan, I'm going to send you a reply. Just tell me if it works. You can try this. Okay. Intent error. One second. So Kapil is talking about some intent error. You mean indent error? So Tyagarajan, I think we'll talk about this offline. Just send us an email with your screenshots, and then we'll take a look. All right. So if you get indent error, right? So let me just talk about indent error in general. So in Python, basically, when you talk about different code blocks, so for example, I write a for loop saying for I in range 20, and when I do an enter, in most environments, in most Python coding environments such as Jupyter Notebook and others, when I do an enter, it automatically indents by 4 spaces. Now sometimes what happens is, in case you're not following that 4-space rule, you might be facing some issues. Secondly, if you're within a code block, it has to stay at those 4 it has to stay at the same indent level, depth of indentation, for example. So if I say for I in range, and I say print I, print, let's say I square, and that's about it, right? I mean, I would face an issue. Let's say I do so I would face an indentation error because the print is not been indented. I mean, because it's part of my for loop. So this would be, for example, a case where I would face this error. So let's say I indent it twice. I would still face the error because I have indented it twice, and then the interpreter is confused as to why there are 2 indentations as opposed to 1, right? So let's try. Okay, so basically, whenever there's some mismatch with respect to indentations, we face these troubles. All right. So essentially, you need to ensure that every time you indent, it needs to be indented appropriately. So if I want to say if I is less than 3, and because within the for loop I have another condition, you will notice that it's indented even more. So I would say so for example, if I run this, it's running smoothly, but notice that there's been an indentation here. If I reduce this indentation and try to run it, it expects an indentation here. So these are some of the issues that happen when you don't indent correctly, right? In general, the principle to follow is that whenever you have a colon, right, and whenever you have a colon and you press an enter, you are essentially starting a new code block. And if you have another colon and you press enter, you are starting a new code block, which is indented by a few spaces. All right. It should automatically do it for you. However, Python would not know where your code block ends. So for example, so I type so if I is less than 3, I say print, and then basically I'm done with the if statement. But and then the subsequent part is part of my for loop, right? But Python doesn't know that, so I'll have to make sure that I pull it back by how much ever I need to, right?
But I can use hash and curly also. Like curly braces on it, I use like.
Meaning?
So if we have a problem in indentation, not understanding indentation, then we can follow the curly braces.
No. So no, I don't think so. So essentially, one of the classroom participants wants to know that if I don't want to use indentation as a method to specify code blocks,
Make it more readable. Code. Make the code block more readable. Like use curly braces, hash curly braces.
you
To
could
show
do
the
that. Yeah. So see,
code block.
right, you could do that, but I don't think it's recommended.
For loop is closing.
No, I understand, especially so those of you that come from different programming backgrounds who are very used to using parentheses or curly brackets to specify code blocks, you might be tempted to do that. But if you look at like let's say one of the things I've shared with you guys is the style guide, the coding style guide. I mean, this is of course just recommended stuff, but you know it's so once you start getting used to writing Python code, right? Uh, I think you may not feel the need for that. I see where you come from, though. I completely understand where you come from, but I would still say try and avoid it. Because the thing is, so a huge part of our journey while we sit to program and all, right, is that we'll end up reading a lot of code online too, right, written by other programmers when we are trawling through these different trading portals or any website. You'll keep coming across whether it's shared by me or what you find on the net or through friends or whatever. Uh, you would not find that specific, using something specific to you. You may not find it otherwise. So just to make your own mind more used to reading Python code, I would just stay away from it. Okay. Um, so, Maddie, I hope you understood that basically when you run a code block, right, you have to figure out where it ends. In the sense, the code block that you ran. Let me just check. Yeah, so in a case like this, you need to know that, okay, this print, for example, is for the entire range and not just for my if loop. So one has to be a little careful there when you're writing it. All right. Okay. So Daniel, I'm going to sidestep that question on exponential moving average, at least for now. We'll try and talk about it when we do the next class. All right. So basically, when you run a for loop, it is in a case like this, your range 5 means it's 0, 1, 2, 3, and 4. So in a sense, it's going to run 5 times. Your for loop is going to go through the entire. It's going to go through this cycle like 5 times. I hope that's what you asked. I'm not quite sure I understand your question. Okay, I think so you don't need to leave any lines as such. So when you're writing code, right, I think you want to know how many times how many lines need to be left. That's so the white space that you leave is entirely upon you. There's no, so you could very well write it just below the for loop statement. I mean, you don't need to leave, you don't need to keep going to a new line after you type out your code. The whole idea of spacing it out is just to make it a little more readable. So it's not necessary for you to do it in that manner, right? Okay, so I think Adrian wants to know, are we going to learn about data storage? Not so much about data storage, Adrian. We will be talking about strategies and stuff, but you know, there will be some sessions where we do talk about using backtesting engines, whether it's to do with interactive brokers or anything homegrown. But I'm not. So I guess the instructors there might touch a little bit upon the data storage bit. Okay. So I don't see any more questions coming along. So I think what we'll do is we will stop it here for today. All right. And in a day or so, I'll be sharing the file that we'll be covering next week. All right. So you can spend some time going through the file. It'll be pretty useful if you at least read through some parts of it before you come to class, because it'll just help. I mean, like the last time, we will be covering quite a bit, and uh, you know having a look at it and coming to class will make it that much more useful to you. All right. So Maddie, if you have any more questions with regard to this, I suggest you write to us, and we'll take it from there. So Jatin, we will be doing the back testing next Sunday when we meet. This was more, I viewed this more as a tutorial session. So Ismail, the second and third parameters of the np.where are what you do if it's true and what you do if it's false. You can, essentially just do an np.where and a question mark, and you'll know what I'm saying. So you can just try this out. All right. Okay. All right, guys. Thank you very much. Have a good Sunday evening, and I'll see you guys in about a week. Bye.